Next question is, number of elements in the range set of f of x is equals to greatest integer of x upon 15 into minus 15 upon x greatest integer for all x belongs 0 to 90 are. So let's solve it. So since we are seeing it is written as product of two greatest integer, so the given interval x belongs to open interval 0 to 90, we will divide at every point where any one of the quantity can become integer. So if first quantity if you are seeing here, so x will be divisible by 15 means it will becomes integer. So all the multiple of 15 in 0 to 90 we will break the entire interval. So we can say when x will belongs to open interval 0 to 15, or we can say when x is belongs to close interval 15 to open interval 30. We can say when x will belongs to close interval 30 to open interval 45, and when x will belongs to close interval 45 to open interval 60, and when x will belongs to close interval 60 to open interval 75, and when x will belongs to close interval 75 to open interval 90. So if you will see first quantity of the given product, when x is in open interval 0 to 15, so numerator is in between 0 to 15 and denominator is 15. So obviously numerator is less than denominator because x is in between 0 to 15. So x is in between 0 to 15. So whenever you will be dividing by 15, obviously it will be coming a fraction. So fraction greatest integer will be 0. So whenever you will be multiplying 0 to any quantity, the second quantity which is given greatest integer minus 15 upon x, whatever will be coming calculated value for x belongs 0 to 15, whenever we will be calculating it, first quantity since becoming here in between 0 to 15 in open interval 0. So overall product will be 0. So we will be getting here f of x will be coming in this interval equals to 0. Similarly, when x is in close interval 15 to open interval 30, then first quantity if you will see in the product, so at 15 dividing by 15 it will be 1. When x is in between 15 to 30, at 30 it will be 2. So in between 15 to 30 it will be 1 point something. 1 point something greatest integer will be always 1. So this quantity is coming 1. What about second quantity? Now we have to observe here. So denominator is exactly 15, so it will be coming here. We will be writing here, just write down. When x is in between close interval 15 to 30, first one quantity is coming 1 into second quantity if you will see, if it is 15, so 50 upon 15, it will be 1, so minus of 1 greatest integer minus 1. And when x is in between 15 to 30, obviously denominator is greater than numerator, it will be coming a fraction, but negative fraction. Negative fraction greatest integer will be minus 1. So at 15 also it is giving you greatest integer minus 1, and in between 15 to 30 also it will be giving you greatest integer minus 1. So here it will be coming equals to minus of 1. Similarly, when x is in between close interval 30 to 45, first one quantity if you will see, so first one quantity is coming at 30 dividing by 15 it will be coming 2. And when x is in between 30 to 45, since at 45 we will be dividing by 15, it will be 3, but quantity is in between 30 to 45, so obviously it will be 2 point something, 2 or greater than 2 but less than 3, so its greatest integer will be always 2. And second one quantity if you will see, then at 30 minus 15 upon 30, it's a fraction, obviously it will be coming minus 1. And for 45 means in close interval 30 to 45 completely you can see denominator is greater than numerator, it will be coming a fraction, but negative sign will make it negative fraction, so negative fraction greatest integer will be minus 1. So it will be giving you output minus of 2. Similarly, fourth one if you will see, when x is in between 45 to 60, so at 45 it will be 3, at 60 it will be 4, but it is less than 60, so it will be 3 or 3 point something. So 3 to open interval 4, 3 in close interval to open interval 4, greatest integer will be always 3. So first quantity we are getting 3. And second quantity if we are seeing here, so second quantity is coming, obviously fraction, negative fraction, greatest integer will be -1. So it will be equals to minus of 3. Similarly, when we will see, when x is in close interval 60 to 75, so at 60 dividing by 15 it will be 4. At 75, if we will be seeing here, it will be coming 5. So 75 in open interval, so obviously quantity will be always coming close interval 4 to open interval 5. So close interval 4 to open interval 5, greatest integer will be always 4. So we can say in that case f of x will be equals to 4 into second one quantity, obviously again it is coming here denominator greater than numerator, so it's a fraction, negative sign will make it negative fraction, greatest integer will be -1. So on product of this it will be giving you -4. Similarly, when x is 75 to 90, so at 75 it will be 5, at 90 it is 6, but 90 is in open interval, so quantity will be in close interval to 90, so greatest integer will be in close interval 5 to open interval 6. So close interval 5 to open interval 6, greatest integer will be coming here 5. So we can write down f of x is equals to 5 into this quantity, again denominator is in between close interval 75 to 90, so numerator is 15 only, obviously fraction, negative fraction, greatest integer -1, so we will be writing a -1. On doing product of this we will be getting minus of 5, right? So they are asking number of elements in the range set of f of x. So range is coming basically 0, -1, -2, -3, -4, -5. So number of element if you will be counting here, so it is coming here 6. So answer key for this question is 6. Next question is, if f of x is equals to fractional part of x plus fractional part of x plus greatest integer of x upon 1 plus x square plus fractional part of x plus greatest integer of x upon 1 plus 2x square plus dot 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 fractional part of x plus greatest integer of x upon 1 plus 99x square, then value of greatest integer of f of root 3 is. So let's solve it. As we know that fractional part of x plus any integer will be exactly equals to fractional part of x. So we can see that the given quantity greatest integer of x upon 1 plus x square is after all an integral value. So we can write down the given quantity in simplified manner as it will be fractional part of x, first quantity as it is. Second one quantity is coming fractional part of x plus greatest integer of something. So greatest integer of this quantity will be obviously integer. So fractional part will be according to this property, it will be fractional part of x only. Similarly, this quantity is again an integer. So x plus some integral value, fractional part if you will be seeing here, so fractional part of x only it will be coming here. In the same manner if you will be proceeding here, so last also it is obviously an integral value and this is x. So x plus some integer, fractional part will be x only. So from here, number of element if you will be seeing here, so it is 1, 2, 3 like that 99. So 99 element this and 1 element is also there. So overall 100 elements is there. So we are adding this fractional part 100 times. So we can say here f of x is exactly equals to 100 times fractional part of x, right? Now f of root 3 we will be observing here. So f of root 3 will be equals to 100 into fractional part of 1.73. Approximately we can say root 3 value is 1.73, right? So f of root 3 is equals to 100 into fractional part of 1.73 is equals to 0.73. On doing product of this we will be getting f of root 3 is equals to 73. Now 73 is the value of f of root 3. So f of root 3 greatest integer when we will be observing here. So greatest integer f of root 3 is equals to greatest integer of 73, which is nothing but 73 only. So here Answer will be 4. Fourth option is correct. So next question is, the sum of all possible values of n where n belongs to natural number and x is greater than 0 and n is greater than 10 less than or equals to 100 such that the equation greatest integer of 2x square plus x minus n is equals to 0 has a solution is equal to. So let's solve it. So if you will see, the given equation is greatest integer of 2x square plus x minus n is equals to 0. N is here, natural number it is given, and 2x square is an integer and natural number is obviously integer. So this quantity and this quantity is integer. So overall calculated value is coming 0. So necessarily x should be also integer. So here we can say x will be integer, then only it can be equals to 0. So now from here you can say integral greatest integer will be always that integral value. So you can write down 2x square plus x is equals to n we are taking on this side. So we can write down 2x square plus x is equals to n. What I had done here, greatest integer of any integral value is that integer itself. So x will be integer only. So in that case 2x square is obviously integer. So its greatest integer will be 2x square only, right? So 2x square plus x is equals to n we are taking on that side. So now if you will see, x will be greater than 0 and n having restriction that it should be greater than 0 but less than or equals to 100. So x greater than 0, so x is an integer. Let's start checking here. So if you will be taking x equals to 1, so if you will be seeing here 2 into 1 square plus 1, overall this value is coming here 3. So this is the value of n. So n is equals to 3 is lying in between 10 to 100. No, so x equals to 1 is not possible. Similarly x will be equals to 2. Then you will be checking here, so it will become 2 into 2x square. At the place of x we are putting here 2. So 2 into 2 square plus 2 will be getting here 10. So n value we are getting 10 when x is greater than x is equals to 2. So n should be greater than 10 and it is coming 10 only. So x equals to 2 is also not acceptable. Now we will be checking for x equals to 3. So we will get here at the place of x obviously we will be putting 3. So we will be getting here 2 into 3 square plus 3. So its calculated value will be coming 21. So n is equals to 21 when x is equals to 3. So 21 is the possible value of n which is lying in between 10 to 100. So x is equals to 3 is acceptable here, for which 21 will be the possible value of n in the given restriction. So similarly if you will be checking for x is equals to 4. So x is equals to 4 when we will be putting in this equation. Let's suppose this equation is equation number 1. We will be getting here 2 into 4 square plus 4 is equals to n. So its calculated value you can see it is coming here 16 to the 32 plus 4 36. So n is equals to 36 which is acceptable in between 10 to 100. So this is also x is equals to 4 acceptable. Similarly when x is equals to 5, in that case if you will be checking here, so again putting in equation number 1 at the place of x, x is equals to 5 will be getting 2 into 5 square plus 5 is equals to n. So calculated value we are getting here, 55. So n is equals to 55 is also acceptable value which is in between 10 to 100. So x equals to 5 is also we are considering. X equals to 6 if you are taking here, so it will be coming here 2 into 6 square plus 6. So that quantity equals to n. So on calculating this value will be coming 72 plus 6 78. So n is equals to 78 is also acceptable. So now if you will be checking for x equals to 7, so 7 square obviously 49 and into 2 98, 98 plus 7, it will be exceeding 100. So greater than 6, any integral value of x will be not satisfying, and less than 3, any integral value will be not satisfying. So now we can see here the all possible values of n is, n can be, we can write down 21, 36, 55 and 78, right? So sum of all these possible values, if they are asking, so we can do here 21 plus 36 plus 55 plus 78. So on calculation of this, we will be getting 190. So 190 is the answer for this question. So option number 3 is correct.